This video examines the tuning of the hot air pressure controller and the hot air temperature controller. We will examine the loops in the sequence suggested in the previous video, but not as part of plant startup. Instead, the process is operating and each controller has been previously tuned. Our objective is to assess how well each loop is tuned and make adjustments if appropriate. Our starting point is the process at its normal operating conditions. All controllers are on manual. We begin with the hot air pressure controller. The hot air pressure responds rapidly to changes in the fresh air damper opening. This permits the hot air pressure controller to be tuned aggressively. To display the tuning parameters, left-click the PNI diagram element for the hot air pressure controller to open the point window. Then expand the parameters menu. Positioning the cursor over the tuning parameters menu item displays the current values of the tuning parameters. The controller gain is 4% to percent. The reset time is 0.2 minutes or 12 seconds. Switch the pressure controller to auto. To change the controller mode, right-click the displayed value of the mode. The current mode is manual, so click Yes to confirm the proposed switch to auto. Change the set point from 2.5 to 3 millimeters of mercury. To change the set point, right-click the displayed value of the set point. Then enter 3 for the set point and confirm by clicking OK. The hot air pressure is assigned to the green pin. The loop responds rapidly with no overshoot. Change the set point back to 2.5 millimeters of mercury. Our objective is to determine if the loop responds differently to decreases. It does not. Place the simulator on hold. Then expand the scales for the trends. The pressure dynamics are very fast. All dampers have a 10-second travel time, which is a significant contributor to the behavior of the hot air pressure loop. Most likely, the hot air pressure controller could be tuned more aggressively. But when a loop is fast compared to the other loops, more aggressive tuning is unlikely to improve overall performance. The critical variables are the off-gas temperatures. They must remain above the dew point. Better performance of the hot air pressure loop is beneficial only if it leads to better performance for the off-gas temperature loops. The current performance of the pressure loop is probably more than adequate. Restore the trend to its default. Next, we examine the hot air temperature controller. As currently tuned, the controller gain is 1, and the reset time is 1.5 minutes. The dynamics of the hot air temperature loop reflect the slower dynamics associated with the thermal mass of the furnace. Hence, the longer reset time of 1.5 minutes is to be expected. Switch the simulator to run. Then switch the temperature controller to auto. Then change the set point from 210 to 220 degrees Celsius. The hot air temperature is assigned to the red pin. The loop responds much more slowly than the pressure and exhibits a small overshoot. Switch the simulator to hold. Although just barely, the temperature loop exhibits an oscillation. This permits the value of the reset time to be assessed. A rule of thumb is that the reset time should not be shorter than half the period. the first step is to determine the period of the oscillation. With the simulator in hold, a vertical white line tracks the cursor when within the trend region. The current values and the time that corresponds to the vertical white line appear in the upper top 4 lines of the trend window. The first peak occurs at about 2 minutes 52 seconds. The second peak is only barely visible, but occurs at about 5 minutes 17 seconds. The difference is the period of the response, the value being about 2.5 minutes. The reset time of 1.5 minutes is greater than half the period. The current value for the reset time is reasonable. What about the controller gain? The overshoot is modest, and the oscillation is barely visible. No need to decrease the controller gain. Increasing the controller gain would increase both the overshoot and the oscillatory component of the response. Let's go with what we have. Switch the simulator to run. Then return the set point to 210 degrees Celsius. The response to the decrease is about the same as for the increase. The next video will examine the tuning of the baghouse inlet temperature controller.